In the third question, we do not heat a product, but we remove heat in order to freeze ice cream. We make this ice cream with a scraped heat exchanger in which the product mix is partially frozen at -4 degrees using liquid ammonia on the outer side, which has 250 Kelvin, which is actually cooler than -4. The question is how much exergy is lost if we take the environmental temperature as 293 Kelvin. Once more, we have a heat exchange process. We have a wall. On one side we have the product at -4. On the other side we have the ammonia, which has a temperature of 250 kelvins. And of course in between there is a temperature gradient. We know a little bit more because we also know the reference temperature of 293 Kelvin. Then the question is how much exergy is lost. Once more we can use a similar equation as we used before. However, there is a difference now because heat is being lost from the product. And you might remember that in a cooling process, actually the exergy flows in the reverse direction. So the exergy actually flows from the liquid ammonia into the product. And that's logical because the product moves away from the standard environment and therefore gains exergy. Well, we can express this with the equation that we saw before. However, now the two temperatures have been reversed. So it is T0 minus the T, and that is because we are now below T0. Otherwise we would have a negative exergy. Well, let's have a look what we know. Do we know the reference temperature? Yes, we do. We know the product temperature? Yes, we do. And on the other side we also know the ammonium temperature. And well, do we know the Q? No, actually not. Nothing is said about this, and this is a problem of course because, well, we need it to calculate the exergy. However, if we think back to the previous question, there we were supposed to give the amount of exergy lost in as a fraction of the total heat exchange, and of course we can do the same here. If we do that, we will be able to answer the question without needing any additional information that is not given. In this way we can both find the exergy that is gained by the product and the exergy which is lost by the ammonia, and the difference will give us the total amount of exergy lost as a fraction of the total heat that is being exchanged.